Testing, testing, 1, 2, 3. Hello, hello. Thought I'd stream some more TinyRange development. Getting right into it, since I have actually done something, one or two things since last stream. So if you look down the bottom of the README, which is published now, it'll have a little section on rebuilding the ext4 ext4_gen.go file. That uses a little struct gen tool. This just means you can make modifications to that file. So the input is the .strut, which contains all of that, and then that's turned into the Go file, and that's used by the ext4 driver code. So now, moving on to this. Next step is boot a full Linux distribution from an OCI image. Okay. Let's get right into that. So, what do I mean by OCI image? What I mean by an OCI image is, I mean a Docker image. The ability to run an OCI image essentially turns into the ability to run whichever Docker image you like in the system. OCI is a little more general than that, but that's the gist of things. Depending on how we implement the OCI code, it'll also support pulling from other registries besides the default Docker registry, but we will start with the default Docker registry. I won't worry too much about optimizations of this, because the goal of moving forward with this is that eventually I can integrate the work that I'm doing here with PKG2, which is another open source project I've been doing that will handle the actual fetching and package metadata and includes all built-in caching systems and stuff like that. But let's get OCI images working. Extract OCI image library outline tag latest and extract that into the file system. And if that fails, just return error. So let's just write a file system .ext4 string error. So firstly, from a registries template, we're going to implicitly assume that this means the default Docker registry, which the default registry is this one here. And you can pretty much just make a request. So again, referring to previous code I've already written, since the technical details internally of actually downloading an OCI image is quite annoying. We'll make a func make request wrapper method string URL string. We're not going to use any other libraries for this, simply because I don't feel like it. Well, no, more precisely, we're not going to use existing libraries for this because we want to do a fair amount of customization of how this kind of thing works internally. And the kinds of libraries don't always support that. So we will make a request. This will be a registry request. Request equals and let's make registry request. This is going to be talking with an HTTP API, but honestly, it's mostly just parsing a bit of JSON and extracting some tar files. That's all OCI images are. They're JSON and tar files. Which, we've already done tar files, and parsing JSON is no difficulty, so this part's probably going to go pretty quick. Request. We are going to have to make the stateful. We'll make it stateful because most OCI image requests actually require authentication. Even pulling publicly available image from Docker requires authentication. So the first step that we're going to have to do is we're going to have to request access token from Docker to be able to perform that download. And Docker doesn't restrict handing out those in any way, but we have to do it anyway. Error. Image downloader. Extract OCI image. Client.do request. Status code equals 200. HB.status okay. Return rest no. You may wonder why we're adding hard-coded support for accept headers into this. Because the Docker registries are actually really annoying in that they love to switch what your response does based on what accept header you send. Which I think is an absolute pain, but it's a thing. Set found. Except has an array of string. Right. And else failed to handle response code. So the downloader firstly starts by download image index manifest URL printf @s name graph a equals strings.cut name don't actually need that. So if we look at this format, which we can of course do like that. This is just, the first part is the image name, This can actually be quite a lot longer than that, depending on what registry you're using. And then the second part is the image. The second part is the image tag that's associated with it. Oh, sorry, image reference. And yeah, this part of this is just dealing and supporting other registries. Doing downloads directly from Docker's registry is not that difficult, but then you get into like GitHub's registries, Microsoft's registries, all sorts of other registries. Why those other registries are useful is because a lot of Docker images will be either hosted there or referenced there in some way or another. So manifests, default. We'll always use the default registry for right now, and we'll do image name, and we'll do ref. Slog.info. We will add a slog.info request method URL set accept headers. Okay. And right, so now we're going to do it's going to be get request. The URL is going to be the manifest URL that we created, and accept is going to be these two here. Error is rest error, tail error. Just return error. Rest.body.post. And the first of a few JSON records. Deck JSON.moviecoder rest.body index image index 2 deck.code into index and if this returns an error, and return the error. And we'll just wrap this in something a bit simpler. Since we're probably going to end up having to do a few of those. That's just going to be URL. That's going to be accept headers, and this is going to be method. We're decoding into the output directly, and if that works, then we're returning index, image index v2, and error download JSON get URL. index errors nil return error. Okay, we get a 401. We get a 401 unauthorized as a response. Don't be discouraged. This is how it's supposed to be, actually. Because the unauthorized response says that we need to actually need to remake the request. So now we have a token, and we will method allow accept headers. And we just need the token response. The token response. And we just need the token response and pause authenticate. We'll move all this code into a separate file later. But if we do this now, we can see that we got a valid response. Like I said, it doesn't actually prevent you from doing any of this. It just requests that you're properly authenticated. The reason, I guess, they're doing this is so that they can rate limit things or potentially require logins in the future. I have no clue, but this is how it works right now. And this code seemed to be relatively stable over the past while that I've been using it. So the next step after we get index is to switch on the switch on the schema version. If index if manifest.schema version, if index.schema version is equal to 2, else then just on condition and return got this big giant object instead. And then we need manifest ID. And then we need to download the manifest. Let's call this index URL, and manifest URL is equal to printf. The reason you need to do the second step of indirection is because these modern Docker images support a whole bunch of different architectures that they can run on. So we need to figure out what architecture is matching whatever version we're trying to set this VM up for. Right now we're just hard coding it to ARM64, since our VMs are not ARM64, MD64. But in the future, just replace that with whatever architecture you want to look for. Just be aware that cross-platform Docker images, cross-architecture Docker images like this are a relatively recent addition, and sometimes it can be a bit difficult to find the architecture that you're looking for across a different image. Like, for instance, if you want RISC-V, I'm not sure there are that many RISC-V Docker images, if any at all, right now. When TinyRange boots RISC-V VMs, which it can do, it downloads the Alpine mini rootfs's like we were doing before, which you can of course do as well. So the manifest URL is this, plus the image name, plus the manifest.digest. And this is going to be an image manifest. Like I said, just a whole bunch of JSON. Config identifier and image layer identifier. Luckily, we are pretty much at the last step for this. For at least a basic kind of hello OCI type thing. We're going to skip the config for now. You do actually need to parse the config in most cases, but again, we're just hard coding things at the start. Okay, so we've got a manifest URL and manifest. Manifest image manifest. And if error.json get manifest URL string. Again, you need to worry about what ones you're supporting. And then reference manifest. Also, one of the reasons I did want to work on this today and why I'm going to try and move through the rest of these items a little quicker is just because I want to get to here, make the virtual machine customizable, including customization scripts, so I can add integration into PKG2, so that PKG2 can do builds using TinyRange. The idea being that you can define some arbitrarily big complicated build system that has little intermediate steps within it, and those little intermediate steps will spin up a full Linux virtual machine to take care of all the configuration and setting up of that. So as well as being a useful command line utility in general, as over the past few streams I've demonstrated using TinyRange a little bit already, TinyRange in that instance will also be a useful tool for doing things like package builds. Things like, imagine if you wanted to rebuild all the packages from an old version of Alpine or an old version of Ubuntu from scratch. You could do that inside of a virtual environment with the correct package dependencies already set up. Also, spoiler, some of these later streams will probably end up being retro computing themed. Yay. So we should have a manifest downloaded. Now let's just remember what we need that manifest for. So once we have the manifest, for_layer range layers. And now we get to start doing get layer, which in turn turns into get blob. So for each layer we do layer URL is equal to blobs ls default registry. You can set the registry to whatever you like. Image name, and then the digest of it, which is layer.digest. And then we do resp error is dl.registry request, it's a get request for layer URL, and accept headers is just empty, because it'll give us back whatever it feels like. Error is error. So tar.juicy file system dot let me just find that bit of code that we were using before that does the extracting. Extract archive 2. Extract reader to input string, input i.reader, and string fs.st4.equal file system, and this function can return an error. And we copy all of that over to there. This also has a reader, so instead of call input, this is now called kind, where we have a input here instead, and we also have a error, and kind really equals input. Yep, that's good. And then return extract reader to put as f. Simple as that. So, and then we just go file system dot extract reader to. And we are just going to make sure that we've pulled in that code. Oh, also, side note with this. I pulled the VM code into a separate repository called VM. I will actually remove my vended version of VM and switch to using that one instead. So that's actually very easy. That just involves doing that. And changing quickly before I forget. Now, not such useful command. There we go. Let's just look down here. Oh. We traditionally call that FS. Track read to rest.body .tar.gz, and the file system is that. If error and then we return not implemented, but in fact we can just return nil after this. Entry init already exists. Okay. That is because Alpine has an init thing at the top level already. So we want to make sure that we are ignoring whatever that is. So let's just under here filter func header star dot header true. So this just defaults to returning true, but now we do if not if filter nil and not filter header, then continue. This essentially just allows us to say if header dot. So first we'll just do slog dot info header. And we will allow this through. Right, we can see all of those, and then I'm expecting there'll be a top level /init executable. There's an sbin in it. Failed to add directory entry. Oh. Failed to add directory entry. Ah. So this is slightly sticky, but okay. Well, layers are sorted in Docker from most important to least important, and that entity init, is that our entity init? That's the question. Because is that our entity in it? Because it shouldn't be. Okay, it is our entity in it. Okay. let's exclude our little bit of code from this for a second and just see what happens. Is this still going to boot? I see no reason why it shouldn't. It'll just be like a straight Docker image. Okay, and it failed for some reason. Okay. The other option for this, which is probably a little bit easier, is just to add my init stuff. And yes, this is what normal TinyRange does. Is to just add my init stuff before we download the OCI image. So yeah, go fs, which is IOFS. Fork exec, /bin/login, no such file or directory. Okay. Pretty sure it has the login thing already. It checks to see if it exists first. Pretty sure it has login thing already, so we may be making a mistake with that. Let's just have a look at init.star and have it run bin sh instead. Bin sh, no such file or directory. Odd. That's unexpected and a little bit annoying. So we are downloading the whole thing. The fact we are skipping if a file already exists makes me think that we do actually need to fix the order of our layer downloads. So do this for now. Layers is reverse manifest.layers. Layers is manifest.layers, and we'll reverse layers. So right. Fork exec /bin/sh. Not found. Okay. Now we'll return return not implemented here again. Looks good. Well, we have got bin.sh, and its mode should be correct. We have actually got all this content already. So that makes me think that my extract thing is a bit incorrect for some reason. Header dot name if not prefix Okay. So right. Because that login thing should also exist. If this turns out that was the error. Fun. It's annoying. Bin -f. There we go. We can now boot a Docker image instead. I will, just for a little bit of fun, make this customizable. Size flag.int size 64. Library/Ubuntu latest. Type flag not implemented. 49. Okay. What's 49? That's 53. 49's hard link, which I do actually have implemented. Right. Link. Link. Hard links must use absolute parts. Okay. Oh, some, yeah, yes. So that will be. Hard links must use absolute parts because, yes, of course they should. We'll just say in here if header.typeflag equals tar.typelink, header not string for host prefix, header.name, header.link name, that, and header.link name. As expected, failed to allocate extended file system is full or fragmented. The storage size will need to be a bit bigger for Ubuntu. Just give it 512. I only need 128 or 256 meg, but yep. There we go. Now we've got an Ubuntu virtual machine. All right. That does that. Booting a full Linux distribution from an OCI image. So I'm gonna go off and have dinner soon and come back and stream a little later this evening. But before I do that, I just want to fix a few small niggles that you may have noticed as I was working these VMs before. Namely that I was missing procfs and sysfs, and also I don't have a hostname set. Set hostname login and mount proc non/proc mount sysfs. Just check what ones I need to do. Oh, I can check this a lot easier by looking in my star file for this. Ensure path just ensures that the path already exists, but we will always do this. Ensure path. And then that will be there. Init go, and then we will just need a globals set hostname equals starlark.built-in set hostname. Between this and PKG2, I write too many of these little Starlark wrappers for things. I've considered writing some kind of DSL that makes this easier, but it's one of those kinds of things where there's too many edge cases that the DSL will have to represent efficiently. So, like, this part of the template is pretty common across everything. You can see that this has it, this has it. But then if you look at a command like this, it doesn't. It ends up doing something a bit different. So if you end up writing a DSL for it, then the DSL just ends up getting too many weird edge cases associated with it. So we will just do unit host name set host name set host name no, not home name, host name. Did I misspell that all the way through? That'd be annoying. Host name, host name, host name, host name. Check the other file shortly, I think I did. The Unix package in Go is just wrappers around system calls mostly. Yep, I called it set home name. It's set host name. That'll be that one, and then might as well. then all this one's just going to call is mount, and mount options. Woohoo! Oh no! I forgot path symlink. Which is I just need path symlink. Globals, path symlink. What's that? Why didn't you work? Failed to mount dev temp fs on temp. More error equals true. What went wrong now? Okay. How to mount dev PTS. That's kind of necessary, but let's just ignore that for a second and see if this works. I am dumb. I forgot that I didn't do that in show pathing by default. And ignoring error equals true here because the dev file system. Yep. Woot. Can't access G. Can't. Okay, so that's probably because oh. The fact that Control C doesn't work inside these VMs right now is very annoying. ls/dev pts that has ptmax. That can't access to UI job control turned off. That's probably a Qum thing that'll be fixed by the using SSH, which is a later step, which is also going to be a tonight thing. Also, I'm going to move the network caching layer stuff over to other things, perhaps. So let's just modify that. Right. You'll notice for this VM, it now has a name. Oh, and if we were to do something like D3, that would work automatically. PS, that would work automatically. All that kind of stuff. You just need this set of file systems to get a Linux system to think it's a Linux system. Like, if you're missing some of these, then random applications like Docker won't work and other things, just because Linux systems assume all those file systems are mounted. Containers do not contain their own init system. They don't know how to initialize themselves from scratch, necessarily. So we are implementing all of that ourselves, especially because the container image that we boot up may not necessarily even contain anything, theoretically. I mean, the only thing we need to run is our init executable. We could load the scratch image. It wouldn't do anything and it would just crash as soon as it boots up, but why not? Also, we will see that scratch doesn't actually exist, because it is in fact something that doesn't exist. If you scratch latest, oh, scratch latest exists, but it's still 404. If image name equals library scratch, return nil. Like I said, virtual. And if it doesn't happen, then it fails to mount proc. Because this needs to ensure path. That's not the error that it should have. Or execute binlog, it doesn't exist. Alright, there we go. Yeah, and that's pretty much it. There is a whole bunch of other miscellaneous things, but this first stream, like I said, I was going to go out and grab dinner and probably stream again in about an hour or so. So, thanks for watching. Bye.